Welcome back, Night Owls. This is Dr. Nighttime. I know it's been a while. You may notice the change in scenery here. I actually moved between my last video and this video. Anyway, tonight I'm doing a video inspired by a math problem that I saw on social media posted by the owner of one of my favorite math education YouTube channels, Polymathematic. And so this is the problem. If f of x is some quadratic function of x, right, f of x equals ax squared plus bx plus c, and you're given the pieces of information that f of negative 2 is 35, f of 1 is negative 16, and f of 4 is 5, you want to solve for a, b, and c without using matrices. Okay, to be a little more honest here, that last condition, without using matrices, that wasn't part of the problem that Polymathematic posted. This was part of a social media conversation where someone else had said, hey, is this a little too complicated? Like using matrices, is it going to be too complicated for Algebra 2 students? Polymathematic said, well, actually, if students are allowed to use a graphing calculator to do the matrix arithmetic for them, then it's not complicated at all. And I looked at this and I said, hey, I think I see a way of doing it without matrices, and it would mean that students wouldn't have to invert this 3x3 matrix or solve a fully intertangled or fully coupled 3x3 system of 3 equations and 3 unknowns. And if you don't know what matrices and 3x3 systems of equations and unknowns mean, don't worry about that. This video is all about how to use simpler stuff. There are a couple reasons why I want to make this video. First of all, it's a really cool technique that I want to show you. And also, to be honest, you know how cats will sometimes bring along, chewed up dead mice for their owners and present it as like, hey, are you impressed with me? So, Polymathematic, if you're watching this, this is my chewed up dead mouse for you. So, I'd advise, well, let's start by plotting the points that we have here. 1, comma, negative 16, kind of around there. 4, comma, 5, kind of up here. Negative 2, comma, 35, kind of up here. Now, as you can see, these three do not go on a straight line, right? No huge surprise. We're not expecting this to be a straight line, right? It's going to be a quadratic. Now, you can tell, right, if we were to look at the straight line that would connect these, well, this point in the middle, right, it's below them, right? That would indicate that this is curving upward some amount, right? So we're expecting a to be a positive number. If this middle dot were somewhere up here, we'd expect a to be a negative number. If it were right on the line, we would get that a equals 0. And so there should be some way of figuring out, well, based on how far above or below this is, based on how far above or below f of 1 is from the corresponding point on the line connecting the endpoints, we can figure out, based on how much that is, we can try to figure out, well, how big is A? Yeah, you'll notice that this point down here is considerably below this point on the this midpoint on this line segment here. Notice that this 1 is directly, it's right at the midpoint between negative 2 and 4. It perfectly splits the interval. It makes this problem a little simpler. I'll show you at the end how to modify this procedure if the point that they give you for the middle isn't, so they give you a low x value, medium x value, and high x value. If the medium x value isn't exactly at the midpoint between the low and high values, I'll show you how to modify this procedure for it. But for now, we'll say, okay, this 1, right? Well, where would it be on this line? It would be, if a were 0 and this were directly on the line, you'd be at the midpoint here. That's a midpoint between 35 and 5, right? So add them up, divide by 2, or average the two together, however you want to do it. You would be at a 20, right? So this distance here to here, from 20 to negative 16, is a height of 36. Right? In other words, you start 36 points below the line you're supposed to go to, and as you move out 3 in each direction, you eventually reach the line, right? We're getting some parabola that's going through here. And we know that if we just had f of x equals x squared, right? Well, then to go out 3 in each direction, you'd be going up 9, not 36. Right? And that essentially to get the distance between wherever this parabola is and this line, right, you're just subtracting off some linear term, right? So whatever's in front of the x squared wouldn't matter, or it wouldn't be affected. So we could say if a was a 1, then midway through you'd only be 9 below your line, right? You'd only be going up by 9 relative to the line if you moved 3 over in each direction. And we know that from just imagining, well, what if this were the much simpler quadratic y equals x squared between negative 3 and 3? Right? Your endpoints, f of 3 would be 9, f of negative 3 would be 9, but f of 0 halfway between them would be 0. Right? So in that case, right, you're in the middle of an interval going 3 in each direction, and you go up by 9. Similarly here, if your a was just equal to a 1, right, you'd get that same thing. Instead, you're going up by 36. That's 4 times as much. So you get a must equal 4. Now, worth noting, this point down here, this is not the vertex of the parabola. It's the vertex of the parabola you would get if you were to take this ax squared plus bx plus c and then subtract out this downward sloping line. But that for both of those parabolas, you'd still get a equals 4, right? Adding or subtracting a linear, it's going to mess with the middle and the linear and constant terms, but it's not going to mess with this leading quadratic term. Right? Okay, so we've got a equals 4. What the author of this question actually had in mind for students to do is look at this ax squared plus bx plus c and then plug in when x is negative 2. So you'll get 4a minus 2b plus c equals 35. And then plug in x equals 1. A plus b plus c equals negative 16. And then plug in x equals 4. 16a plus 4b plus c equals 5, right? And get that complicated system of 3 equations and 3 unknowns that it's going to be a pain to solve. What you could do, once you've solved for a equals 4, you could just plug that in and then pick any 2 of those 3 equations and just get 2 equations and 2 unknowns, and that would be perfectly fine, right? And it would shortcut out a lot of the work. So even just doing this and then moving to a more conventional approach still saves you some effort. But instead, I've still got some algebraic and arithmetic acrobatics to show you. And if you're worried that this is a little too acrobatic for you, don't worry. With enough practice, a trained circus performer can make acrobatics seem routine. As for you doing this math, don't worry, with enough practice, we'll make a clown out of you yet. So, next thing to look at is the distances between this point here at the 1 and each of these endpoints here. Over here, you're going from 5 to negative 16. This is a height of 21. Here to here, you're going from 35 to negative 16. This is a height of 51. And on this left-hand side, that's actually going to be the more interesting one for this particular problem because the y-axis is on that left-hand side. Now, one thing you've probably noticed, hopefully you've noticed, if you've graphed enough quadratic equations by hand, is that if I wanted to graph just plain old regular y equals x squared, right, I'd start with 0, 0. I'd look at 1 or negative 1, and I'd go up by 1, right? 1 squared or negative 1 squared or 1. I'd go to negative 2 and 2, and I'd go up to 4. That's up by 3 from what I just drew. I'd go to 3 and negative 3. Those go up to 9. That's 5 up from what I just drew. Right? The amount I'm going up, 1, 3, 5. I'm going to go up 7 more to get to 16. Right? It's the odd numbers. And each time I move over, I'm going up by 2 more than I did before. That would be if a equaled 1. With this a equals 4, I know each time I'm going up by 8 more than I did before as I go further and further out, because we've got a vertical stretch by a factor of 4. So I know that as I'm going from this point, -2, 35, to -1, something, to 0, something, to 1, -16, right? I know that in my 3 steps going down, in total I need to go down by 51. So I need to figure out, if I want to figure out how much I'm going down each step of the way, they're not equal steps, but they're evenly spaced steps, if you will, right? The differences between the steps are constant. So I'm looking for 3 evenly spaced numbers that add up to 51. Now you'll know, if you've got if you have an odd number of evenly spaced numbers, you just look at the middle one, that's going to be your average. If you have an even number of evenly spaced numbers that have to add up to something, the average between the middle 2 will be your average. So in this case, right, I've got 3 evenly spaced numbers. The middle drop, right, from f of -1 to f of 0, that has to be a difference of 17, because my average decline is at a rate of 17, right? It declines by 51 over a space of 3. So on average, 51 divided by 3 is a decline of 17. And I know that if a were 1, I'd be my differences would be increasing by 2 here with a equals 4. I'm just doing a vertical stretch by 4. The differences are going to be 8. Right? So I know that to go from -1 to 0, or f of -1 to f of 0, would be a drop of 17. From f of -2 to f of -1, that should be a drop of 25, right? It's a steeper drop here. Okay, so 25 down from 35, I'm going to get -1, 10. And then 17 down from 10, I'm going to get 0, 7, sorry, 0, -7, which is more like here. And then from 25, or from f of 1, or f of 0 to f of 1, right, I'm going down by 9, right, which sure enough does get me to -16. Now, if you see where this is going, I just pointed out that f of 0 was -7. F of 0 is always going to get you the c value, right? A times 0 squared plus b times 0. Those are going to go away. So we just simply get c equals, did I say 7? It was -7. If I forgot to say the negative a few seconds ago and you were screaming at your computer watching this, don't worry, I heard you. And if you want to just keep track and make sure the pattern would continue, right? So you're going down by 9 to go here, 8 less than that, so you're going down by 1 to go to -17, and then up by 7, right? You're 8 up more than you were before. You went down by 1, up by 7 to go to -10, and then 8 up from 7 is going to be 15. You go up 15 from -10, sure enough, you do end at 5, right? And so you've got this parabola here. Okay, so you've got A and you've got C. One thing you could do, you could just plug in your A equals 4 and your C equals -7, plug that into any of these three. Right? Let's say we picked f of 1, right? We'd say 4 times 1 is 4. Plus b, right? So 4 plus b, minus 7 equals -16. Do the arithmetic, you end up with b equals -13. You absolutely could do that. But another trick I want to show you, looking at some of these points, right now that we've plotted some of these points here, let's compare f of -1, where you've got -1, 10, and f of 1, where you've got 1, -16. I'm specifically picking 2 points that are negatives of each other. They're symmetric about x equals 0. You'll notice that f of 1 is less than f of -1. Now, thinking about an equation like this, why would that be? The plus c doesn't make one of them go further down, right? It's just a constant shift. The ax squared, when you're picking two numbers that are negatives of each other, they square to the same number, right? So these will contribute the same thing. The only difference here is this bx. The only reason why this would be lower down than this is if you had some negative number multiplying by your x here. You take the slope of this secant line, right? Negative 16 minus 10 is going to be negative 26, divided by a width of 2. You get negative 13, and you can get b equals negative 13 that way. And so to review, to solve for your a, you can look at how much this middle point missed your straight line connecting your endpoints, right? If it's below, that means this parabola is bending up. If it's above, that means it's bending down. You look at how much it misses by and compare that to what it would do if your a was a 1 or a negative 1. And you say, great, however much more bend I've got, that's what the a is. You can then plot some of the intermediate points by noting that, or by finding the average distance, if you will, and noting that each distance, the differences between your differences, essentially, are just going to be 2 times your a. Plot the intermediate points. Find what f of 0 would be. That'll get you your c. And then compare f of 1 to f of negative 1, right? You need 2 points that are symmetric around x equals 0. Get the slope of the secant line there, and that'll get you your b. Now, one last thing. What if they hadn't given us that f of 1 equals negative 16, right? What if they hadn't given us exactly what's in the middle? What if they had given us that f of negative 1 equaled 10? So now we can't just say, I'm squaring some distance. So now we can't just say, oh, I'm moving 3 to either side. And what would that squared distance be? Instead, what we can do is we can find this point up here on the line. Notice that as we go over by 6, we go down by 30 to go on this line, right? Negative 2 over to 4 and down from 35 to 5. So we're going down by 5 every time. So this point on the line connecting the endpoints, right? Not on the parabola, but on the line connecting the endpoints, would be 30. Okay, so this point somewhere not on the endpoints that they gave you is 20 below. All right? And now we could say, well, suppose our a value was 1. We'd fall the furthest below here when x equaled 1. If we were to go from 1 to negative 1, right, that's a distance of 2, we'd be closing the gap by 4, right, 2 squared. To go from 1 to negative 2, we'd be closing the gap by 9, 3 squared. This distance between those gaps, difference between 4 and 9, that would be a 5, right? So if a were 1, this gap would be a 5. Instead, it's a 20. It's 4 times what it would be if a were 1. So a is going to be 4. I hope you found this interesting and useful. Good way of avoiding needing to solve that coupled system of 3 equations and 3 unknowns. And as always, if you're interested in private lessons, click the link in the description below. And until next time, this is Dr. Nighttime wishing you a good night.